easier to score better through online examinations, I would suggest do not lose your focus. Do not lose your focus on your studies and ensure that the subject matter is something well digested, because ultimately this is only one time issue, and your professional exams are not going to be kind or sympathetic. They are going to be very, very thorough. And there, if you fail once, if you fail twice, if you fail 5 times, and the sixth time you still don't do well, you still don't pass. So that is why it is called certificate of competency. Unless and until you're competent with the subject, they will not pass you. So you have to be good in your subject. Thinking that I sat for it 3 times, fourth time, definitely the examiner will pass me because I've sat for 3 times in the examination. That will not happen in your professional examinations. So do not neglect your studies in the online classes that we are having, because there's nothing else to do except practice at home, practice sketches, read over the subject matter, ask questions, try to answer short questions wherever you can. And there are a lot of mistakes that I found in the papers that you have submitted. A lot of boys still don't know what is the function of the tie rod. Very, very amazing. Very, very amazing. In spite of my repeatedly telling you that tie rod is intended to hold three parts together in compression. One is the entablature or the cylinder jacket. It is the same thing. Second one is the A-frame. And the third one is the bed plate. A lot of boys have written entablature, A-frame, and crankcase. Crankcase is the supporting walls around the A-frames. That is not so much under compression as much as the bed plate is. So it is the bed plate, A-frame, and the entablature which are held by the tie rod. In section, I think section C in particular, the entire class made the same mistake. I feel upset about myself because I probably haven't got across to you correctly. So this is something very, very unusual. I've just started the corrections because 228 corrections takes a lot of time, and I'm reading through everybody's write up. So it is not that because you have written certain paragraphs, you will get the marks. Unless you write correctly, you will not get the marks. You can write a lot of stuff, but if it is not correct, you don't get the marks. Of course, I try not to give poor marks or fail anybody. My point is to encourage you into getting more involved with the subject. A lot of your absorption of the subject depends on your involvement. If you're not involved, but you spend hours and hours of study on the subject, you still will not absorb the subject matter. You need to be involved. You need to feel that you're dealing with machinery, you're dealing with engines, you're dealing with the components of the engine, what it would be like to get your hands on those. That, of course, is still a remote situation with this damn pandemic that has upset everybody's life. So I hope in time we'll get it. So now we have 28 boys. Still, we need another 10 boys to come in. This is section E. Section E has also got 38. So boys are still not coming in. So 30, 28 is there. So we expect a lot of. So if at all we get a.
Excuse me, sir.
Yes, Sastaki, go ahead. What is it?
Good morning, sir.
Good morning.
So actually, I have a doubt. In the connecting rod, so you said that the from the radial side of the crank pin, the oil emerges out. So, sir, I'm having a hard time in understanding how that happens. So, sir, if you can show
Please
us
repeat
it.
your question. Please repeat your
So,
question.
so I am not able to understand that how from the crank pin radially the oil is emerging out. So you said you explained it into the connecting rod classes. You said that from the oil emerges out radially from the crank pin. So, sir, if you can explain it to me through the diagram so that I can understand it better.
Okay. What you're not able to understand how the oil comes into the crank pin, and from the crank pin how it emerges to proceed into the connecting rod. Is that it?
Yes, sir. So the radial, how it flows radially outside. I'm not able to imagine it since we don't have. I'm not able to imagine it. That's the thing.
Okay. I get your point. I get your point. Now we'll get back to that diagram where this particular arrangement is there. And the arrangement is such that the diagram allows the oil to come into the connecting rod through one passage and come out through the connecting rod through another passage. So let's have a look at that particular diagram. Here it is. This is what we see here. Okay. You have understood that there is a common manifold, that means the common pipe which goes along the length of the engine on the inside of the engine. All right. From that pipe, a number of branch pipes emerge to go into each of the main bearings. All right. So here is the pipe which is emerging as a branch pipe, and it goes into each of the main bearing. This one here is the main bearing which is supporting the crankshaft. All right. Now this crankshaft, it has got a drilled passage within the shaft, and that passage is drilled through the main journal, through the web, through the crank pin. The entire pipeline is such that they are drilled passages. And of course, in this diagram, he's not shown you altogether how the passage is correctly made. The hole has to be drilled from one side and it has to emerge out from the other side. Otherwise, it is not possible to drill a hole in the Z format. You can't bend the drill inside. So the drill passage has to be straight. And another passage which has to be meeting that passage has to be drilled at right angles to that. So the hole actually extends right from the surface of the crank web into the end. Later stage, this hole at this point is plugged so that you have a Z format. Okay. So anyway, one thing I hope you understand is that the crankshaft is drilled right through and through. So that passage allows the oil to come in. Not only is it drilled along the axis, it is also drilled radially. This radial drilled passage allows for the oil to enter into the crankshaft. At the same time, some of the oil will lubricate the bearing itself. Now let's have a look at that sketch of a crankshaft that we had earlier. And this crankshaft is, where is it? Yeah, yeah. Now you see these holes that are there. Now this is the crank pin. This is the crank pin. This is the crank pin. And this is also the crank pin. So the oil passage is entering through the main bearing. See, this is the main bearing. 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 So 1, 2, 3, 4, 5 supports are there for the crankshaft, and these form the main bearing. All right. So the oil enters through this hole, passes through the shaft, comes through the web, and then emerges from the hole in the crank pin. That is what the passage of the oil is. So all these branch pipes which you saw are coming into these holes which are on the main bearing. The branch pipes are coming onto main bearing. So all these holes are connected within through passages inside the web, crank pin, web, and journal, again crank web, crank pin, web, journal. So there's a continuous passage right through the crankshaft, and this is shown by the diagram, what you see over here. Where is that diagram? Yeah. No, not this. Where did it go now? Yeah. So you see that passage, what you see here is right through and through. So once the oil comes in from there, not only does it lubricate the bearing that is already rubbing inside, it allows for the rest of the oil to pass through the passage and come to the crank pin. On the crank pin, it emerges out of the crank pin. You saw the hole just now that I showed you. So some of the oil helps in lubricating that passage. And then while it is rotating only, the pressure of the oil will send the oil right up to the connecting rod to lubricate your gudgeon pin bearing. Now, in this case, this particular diagram that you see, it's a complicated case, not easily seen in marine engines that you will be working on. This particular engine has got, now who's come? Satyanarayan. This particular engine has got two passages inside the connecting rod. If you see the side view of the connecting rod, you can see there are two passages which are drilled through the connecting rod. One passage allows the oil to go upwards, and the other, and after it goes upward, even the gudgeon pin has got a drilled passage. So part of the lubrication is lubricating the bronze bush and the gudgeon pin, and the rest of the oil enters into the gudgeon pin and travels to the side. Once it travels to the side, there is a hole emerging from the gudgeon pin and into a hole which is made or cast in of the boss of the piston. This part is called the boss because it is supporting the beam. The beam is the connecting rod. The boss is supporting the strut, and the boss has got a passage which is cast in. Further to that, there is a copper pipe which is cast in the crown, and that oil travels through the crown and emerges from the other side of the piston from the boss and comes out through the gudgeon pin through a second passage. And through the second passage, as you can see in the diagram on the right, the oil comes right out and splashes into the crankcase back again. So the whole oil is again collected and recirculated. So that's how the oil actually passes through. All right. So the oil which is emerging at the crank pin, this is where your doubt is existing. It emerges, but not all the oil goes up to the connecting rod. Part of the oil lubricates the bearing and falls into the crankcase. There is a slight seepage of oil from there because the clearance between the crank pin and the bearing is about 0.25 to 0.28 millimeter. That is less than half a millimeter. So that allows some seepage of oil to provide the lubrication of the bearing. Otherwise, most of the oil which is coming to the crank pin bearing travels up through the connecting rod and proceeds on to further lubrication. Sartaki?
Yes, sir.
Okay. Okay. So that is how,
Uh,
how the
yes,
lube
sir.
oil travels through the crankshaft and then through the connecting rod. Anything else you need to clarify?
Yes, sir. So actually, there was another question that you gave us, that you asked us, that why is the cross section of a connecting rod of medium speed engine or high speed engine is in I section, whereas for a low speed or two-stroke engine, it is in round section.
Sorry,
So
please repeat that slowly. I need to understand your question well.
yes, sir. So you asked us once that why is the cross section of connecting rod of medium speed engine or a high speed engine is an I section, whereas for that of a low speed engine or two-stroke engine, it is in round section.
Yes,
So
that was the question.
yes, sir.
Yes.
So if you can tell us what is the answer for it.
Okay, okay. See, the first thing that is, it is based on, there are two areas that are in consideration. One is the cost, all right, and one is the strength. The steel that we use has a limited strength, all right. So these are the two these are the two parameters that the focus is on. Okay, in the first case, why is the medium speed or high speed engine connecting rod made with an I section girder or H section girder and not a round rod, which is much easier to manufacture? So if you have a round section girder, the mass becomes much more. Whereas if you use an I section girder, the volume and therefore the mass is considerably reduced for the same strength that it can retain. You see the beams anywhere you go and see, they are of I section girders. Why are they not squares, solid beams? Because the square solid beams is much heavier, it is much costlier, there's more material involved. You need to make that beam much lighter, less costly, but at the same time, it must retain the strength. So that is why is the strength required inside that connecting rod as much? in the four-stroke engine. You see, when the engine is running, the mass of the connecting rod is a very serious factor where inertia forces are involved. If the mass is very large, then the inertia forces become very large. In other words, if it is heavy, then the inertia force also becomes much heavier. Now, when this connecting rod is working at a very high speed, the inertia forces are so heavy that the whole connecting rod will bend on either side on account of its inertia, because it is not only reciprocating, it is also revolving at the lower bottom. So if you see the center of gravity of that connecting rod, it is being thrown from side to side. This center of gravity being the center of the mass is thrown from side to side. This, if the mass is very high, it will cause the connecting rod to bend on both sides. And that is largely on account of the heavy mass. If the mass can be reduced, then that whipping forces arising out of reciprocation and rotation, if they are reduced, then the bending of that connecting rod will be severely reduced. So ultimately, what we need to reduce is the inertia forces of that connecting rod. And this can be reduced by reducing the mass. And the mass can be reduced by, instead of having a round or a square rod, you have an I section girder. Moment of inertia is also reduced. In the case of a two-stroke engine, the speed is not so high. Large two-stroke engine I'm talking about, not the high-speed two-stroke engine. In the high-speed two-stroke engine is also a trunk type of engine. There also the connecting rod will be I-section girder. I'm talking about low-speed, large engine connecting rod. You see, there the connecting rod is round section, and there the inertia forces do not cause much of an issue because the revolution is not so high, the RPM is not very high. So the inertia forces affecting the connecting rod is also not very high. If, of course, you can make them I-section girder, then the cost of making an I-section girder becomes much more. So it does not make sense to have an I-section girder for a large bore two-stroke engine where the inertia forces don't arise. Whereas the material cost, yes, there is additional material in the round section girder, so there is some added cost. But the cost of the loss, sorry, if you see the cost of making an I section girder is much more than the cost of benefit arising from removing material from the connecting rod. So there is a cost factor involved in leaving the connecting rod as a round section. It does not cause whipping forces arising out of inertia of the mass of the connecting rod. Whereas in the four-stroke trunk type of engine, because of the higher RPM, the whipping forces and therefore the inertia forces causing bending of the connecting rod will affect the connecting rod, will affect the strength of the connecting rod. So that is why the connecting rod of a four-stroke trunk type engine is made as light as possible. And this is possible only by making it an I section girder and not a round or a square girder. Have you understood?
Yes, sir, I have understood.
Okay.
Uh,
I hope the
so
others are
actually,
also hearing it out.
so actually, there is one last question that I would like to ask. Sir, this is
Okay,
another
go ahead.
question. Yes, sir.
Yeah.
So this is another question given asked by you as well. It was you said that in a air compressor or in a refrigeration compressor, the oil scraper rings or the piston rings are at the top of the top land,
Okay.
and whereas for the engine for engine the rings are not at the top land. The rings are not at the top land. It is after a distance, like after the junk. So why is it so?
Okay. Sasaki, can you answer or give me any concept that you have for this particular arrangement? At least do a little thinking of your own. What do you think it could be?
Uh, Sir, I have no exact idea about it. I was having a lot of thoughts, but then I couldn't figure out what could be the reason.
Okay. Lot of boys, lot of okay. I hope everybody is hearing. This is a very important question. And Sarthaki,
Yes,
I
sir.
appreciate your curiosity and your involvement. This is the way to go. We are great on. Okay, I will answer this question also. And it is a question normally asked of class 4 candidates in MMD. And why are the piston rings in an air compressor or refrigeration compressor located right at the top of the piston? All right. Whereas in a diesel engine or a petrol engine also, the rings are located much lower down. Okay. You see, for any piston ring to function, it has to function within the viscosity of that lubricating oil that is helping reduce friction between the ring and the liner. All right. In the case of a refrigeration compressor or an air compressor, it is working at a certain temperature which is well within the flash point of the lubricating oil. In other words, the temperature of the lubricant which is lubricating the piston ring and liner, is well within the limits of performing satisfactory duty at the TDC. Okay. Whereas in the diesel engine, where there is combustion, the temperature inside the combustion chamber can be anything around 300. Exhaust gas temperature is about 390 degrees centigrade. That is good load. And the temperature on the top of the crown is about that same temperature, 350, 370, 380, something like that. The flash point of lubricating oil is 205 degrees centigrade of standard mineral oil. Of course, now there are additives to raise it by another 5 or 10 degrees, but it is well within the 210 degrees centigrade. Now, if the top piston ring reaches a temperature above 205 degrees centigrade, then what happens? Nothing happens to the ring or the liner. The ring and liner can sustain temperatures of 300 degrees centigrade without problem. It is the lubricating film between the ring and the liner that will start burning out if it goes above 205 degrees centigrade. Above this 205 degrees centigrade, the volatile constituents of the lube oil start evaporating and it leaves behind a semi-carbonized or partly carbonized oil, which then further becomes carbon and then becomes absolutely a solid medium. So that is no longer providing the lubrication between the ring and the liner if the temperature goes above 205 degrees centigrade. Now, if you have the ring located right on top, like your air compressor, then it will reach 300 degrees centigrade. So within no time, the lubrication between the ring and the liner will fail. And moment the lubrication fails, the components fail. And that is the chief cause of failure of virtually all machinery. The machinery component by itself does not fail. It is the lubricating medium between two running surfaces that fail first. And thereafter, the complications arise. Overheating starts, distortion starts, bending, distortion, seizure, breakdown. So it is not the component that breaks down first in a running machinery. It is the lubrication between two rubbing surfaces that fail, which causes the failure of the rest of the machinery. So the same thing happens in the case of a diesel engine if the rings are located way up. And that is the reason why you do not overload your engines. You overload your engines mean the temperature at the ring also will go very high. And then the lubricant will fail and the rings will fail. Seizure will take place, damage to the engine. So it is located at a height from the top edge of the piston after a lot of calculation, a lot of estimates that the temperature will not go above 205 degrees or the flash point of lubricating oil. It is kept below that. So the lubricating oil remains the lubricating oil even when it is working at full load. So same function is with the boss and strut region. That is what you see in this particular diagram. The boss is part of the piston which supports the gudgeon pin, and the strut is the gudgeon pin itself. So this part, the temperature must not go above 205 degrees or flash point of temperature. The bush will not go above 200 degrees centigrade. That is for granted. It is protected. The rest of the piston protects the bush from rising to such a high temperature. But the boss and strut region, that means this region of the piston assembly, where the gudgeon pin is supported by the boss, or rather the gudgeon pin supports the boss, that region must not exceed 205 degrees centigrade. And in the case of your refrigeration air compressor or your air compressor, there is no combustion, there is no heat to the extent of 305 degrees. Of course, the temperature may rise to 70, 80 degrees centigrade, and then that air is cooled and allowed to move on to your air bottle. So 70, 80 degrees centigrade is nothing for the lubricating oil. So the oil, so the piston rings are located as high as possible to minimize the clearance volume of the air compressor and get the maximum discharge. If you have a large clearance volume, then you know the volumetric efficiency is going to drop. Okay, have you got the point, Sarthaki?
Yes, sir. Yes,
I
sir. Yes, sir.
okay. I hope the others have also got the point. These are very relevant questions, and you will not find easily in books. These are actual marine engineering practice questions, and only marine engineers get these information through actual work on board the ship. When you see something failing, when you see a machinery failing, you need to first ask why it has failed. It doesn't make sense to repair a machinery because it has failed. You need to first go into the root cause of the problem. You need to find out why it has caused that failure. And first you rectify or remove that problem, and then you do the repair. Otherwise, a fitter is simply, he just repairs the thing. He doesn't bother why it has failed. The engineer has to make sure to identify the cause of the failure. You remove the cause and then you do the repair. That is the approach of an engineer. All right. Okay, let's move on. And we go, we had finished up to, I remember giving you this diagram. And
Excuse me, sir.
yes, yes, what is it?
Sir, there are a few cadets who are trying to join since 15 minutes, sir.
Of why are they late? Admit. Okay, he's coming. All right, let's proceed. I had already shown you why slippage of crankshaft takes place on the journal. This is an example of how slippage has taken place. That means the shrunk fit journal on the crank web has slipped. And the cause of the slippage, I had told you, it might hit an ice block. The propeller might have hit a ice block on the outside. You might have had cooling or water inside the cylinder. Now somebody's come. Why are these fellows? Another Mukherjee, Somo Mukherjee. He's a disappointment to the name. Anyway, so this is what you see as a slippage, and the markings on the crank web and journal are the places where you will look for the slippage. And what is the cause of this slippage? Overload of engine, hydraulic lock. That means if there is any water inside or fuel inside the cylinder and you start the engine, then that water gets compressed, and water is incompressible. So resulting effect is there's a slippage of the journal. And next question, Sarthaki and all of you I'm putting, it'll be a curious question. Why is it that the main journal is shrunk fit on the web? Why couldn't it be that the main journal and the webs be made of one piece and the crank pin be shrunk on to the crankshaft? So think about it, and in my next class, you let me know why the crank pin is made one piece with the webs and not the journal. It could have been much convenient and there would have been no slippage, isn't it? If the journal was one piece with the web and the crank pin was made separately and shrunk fit onto the web, because the crank pin is not under any torsional load. It is only under compression tensile bending stresses. Okay, so the slippage was the last item we took place, and because of the slippage taking place, and it is becoming a rather frequent issue for high-powered engines. That means very powerful engines are contributing to an enormous amount of torque on the shaft, and such high torque levels are causing some amount of slippage. So this is not exactly possible in very high powered engines. So what is the solution? The solution is welded crankshafts. Okay. So here he says higher demands on power and torque puts limitations to shrunk fit journals and pins, obviously. The solution is welded crankshafts. There are two methods in this development. One, two crank arms welded and making of the crankshaft by welding the crank arms together. And second one is forging a crank throw complete with half journals, then welding the throws with each other to form the complete crankshaft. First case, you have two crank arms. I'll give you the diagram. It becomes much simpler to understand. Two crank arms are welded together to form one throw. And then these throws are welded to other throws at different crank angles based on their firing order to make a complete crankshaft. So let's have a look at the diagram. In the first case, what you see on the left side is a crank arm. That means part of the journal is made for the crank arm, and part of the crank pin is also made on the crank arm, and of course the web is one piece right here. So the web and part of the crank pin and part of the journal forms one crank arm. All right. Now this crank arm has another crank arm which is welded, and this welding is made at the point where you see the arrows. All right. So if you join two crank arms, you will get a complete crank throw. All right. The moment you have a crank throw, you have multiple number of these crank throws which are again welded to each other, and the weld faces are shown in these what color is it? Maroon colored arrowheads. So once you weld them, then the entire crankshaft becomes a very rigid, strong crankshaft, and the stresses are removed or reduced by having them made hollow as possible, keeping in mind what is the torque value that they are going to transmit. A hollow crankshaft will mean a lighter engine. In other words, the dimensions of the engine will have to change, and they are much lighter for the same power output that was being got out from a solid crankshaft. So these are the advantages of the crankshaft where they are welded together and they are made hollow with the objective of making the crankshaft lighter. Therefore, the engine also becomes lighter. Therefore, the dimensions also become changed. There is one particular area you need to understand. What is overlap of crank journal and crank pin? Overlap of crank pin and crank journal is something like what you see here. If I increase the diameter of the journal to make it very large, okay, of the journal. Similarly, I increase the diameter of the crank pin to make it very large. So much so that the diameter of the crank pin and the diameter of the journal, they overlap each other partly at the circumferences. Okay. So what do I get? I get a very rigid, strong crankshaft. If you see the crankshaft here, yeah, let's see the crankshaft here. When the force is put here, this web, it has a tendency to bend and it has a tendency to twist. And once it bends, this side is under tensile stress, this side is under compressive stress, and the web is subject to a lot of stresses. So distortion of the crankshaft is possible. Now, if I have this if I have the journal very large diameter and the crank pin also very large diameter, then the condition of the web bending does not arise. Then if I change the design by making the crank pin large diameter and the journal also very large diameter. And if you look at it actually, that part where the circles are overlapping each other is called the overlap of the crank pin on the journal. And this gives enormous rigidity of the crankshaft, particularly at the web. So this rigidity is possible in a welded crankshaft. So, I mean, it is not really there, it is here. What is the advantages of a welded crankshaft? Reduced principal dimensions of the engine. If you have a welded crankshaft and it is hollow, then the entire engine becomes much lighter. The web becomes thinner because there is lightness of the crankshaft makes the web possibly much thinner. Otherwise, you'll have to make a very heavy web also. So reduced web of the web thickness results in considerable reduction in weight. Moment you reduce the web thickness, you can increase the size of the crank pin, you can increase the length of the journal, you can increase the length of the crank pin, and you can increase the length of the journal because the web has been reduced. And moment you have a large diameter crank pin and a large diameter journal, then the area for supporting the forces has also increased. Therefore, pressure per unit area is also reduced. Moment you have reduced pressure per unit area, then the wear and tear is also reduced. Lubrication is easier. Load on the shaft also becomes lesser. So these are the advantages that are with welded crankshaft. Freedom to choose large bearing diameters without overlap restrictions. This overlap restrictions is not there because what the throw is ultimately from the center of the crank pin to the center of the journal. This remains the same. It is only the diameter of the crank pin is increasing, diameter of the journal is increasing. So the throw remains the same. So uh, when it rotates, the stroke will remain the same. But the diameter of the journal, diameter of the crank pin is larger, means the surface area of contact is increased, therefore pressure per unit area is decreased. So this reduces stress on the crankshaft. Okay, last part is something that goes beyond the scope of our subject because that is involved with torsional vibrations. Torsional, axial, radial vibrations is something on crankshaft we will do in the sixth semester. Right now, it is not within the scope of our subject. But increased stiffness of the crankshaft results in higher natural frequencies of the torsional vibration. You might be curious to know what you mean by natural frequency of torsional vibration. Okay, now let's have a look at it. Suppose I have a shaft, a long shaft, all right, and on that shaft, I weld a piece of a bar on that, okay, and I have two weights on either side. Oh, this doesn't stay only. Anyway, there are two masses, one on this end and one on this end. And this end of the crankshaft, I fix onto a wall. All right. So this is fixed onto the wall. And then I twist this and I let go. So what will happen? It will start vibrating like this. It is like a spring. It'll keep vibrating and then come to a stop. Okay. So this vibration that is happening is a torsional vibration. All right. It is rotating in either direction and causing a torsional vibration. Now, this is not within the scope of your fifth semester, but it's an introduction to vibration of shafts. So as it vibrates, and then it comes to a stop, all right? So there will be a particular frequency when I twist it and I let go. So it will start vibrating at a certain frequency. Oh, I've got a call from fleet management. Just a second. Very lucky. Seventh semester is getting, fifth semester is getting its fleet management in December. This virus. This virus message takes most of your time. Fifth semester, December, fleet management. Good morning, Mr. Nair. I was taking classes, so that's why I couldn't take a call. No problem. Go ahead. Yes, yes. Yes, that's right. That means the first seven have taken short placement in maybe in shipping companies, and on some of them have gone into shore-based Indian Army, sorry, Indian Navy, Border Security Force. They have also chosen theirs because some of them are very keen on government jobs. They probably feel more security with government jobs, so they are taken there also. Some of them want to go in for some other line of service. A few of them have been taken in NYK ship management and in Anglo-Eastern. These are the two main companies. Yes, yes, those have been placed. Or they are looking for an opportunity which is other than shipping. So out of 250 boys, about 25 to 30 have already gone. Not all of them are top rankers. Some of them from the lower rankings have also gone. Yes, 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 yes. These are the best guys. Yeah, yes, yes. IT, yes. IT also, some of them have chosen. Yes, they have chosen companies from various places. And no, all online. After March, it has been always online. Actually, they have been waiting for fleet management because fleet management was expected to come in the first week of March. And then it kept delaying. They had given me the list, and then everything stopped. So they were not sure what to do. If they knew that fleet management is going to positively come, they would have remained in the company, in the list. But now they've already given their confirmation to the other places and other companies. That is the reason. Otherwise, the top ranker was waiting for fleet management only. Everything has got upset this year with delays and delays because of this pandemic. It has caused a little upset amongst the boys also. They are very anxious. But nevertheless, the best of them are still there. And we got only about 20, 25 placements as of now. And most of them are still waiting for your company to take over. The 1 to 7 have already gone. Actually, 1 to 7, they're capable of getting anywhere, any type of, because they are definitely very good. Not that below 8 are anything less, but below 8 are the ones who are keen on fleet management itself. They are following up on the seniors. NYK has taken 5 of them, but not necessarily all of them in the top 7. Some of them are from lower ranks also. But 2 or 3 of them are in the top ranks. And I think one of them is in Tom Shipping, and the others are in IT. One has gone for Border Security Force. Some of them want to appear for IAS. Those they have kept themselves out. Yes, yes, yes. Because now it's a BTech degree, graduation degree. They have the option of pursuing other aspects other than shipping. No, he's not seventh, is he? He's I think 14th or something. So he's seventh. Okay, okay. Yeah, yeah, yeah. Yes, yes, yes. So, oh, he was not allowed. He was not allowed. Okay, sorry boys. That was Mr. Nair from Fleet Management. Now he's asking very, very relevant questions. And those five boys who I hope you've heard about them, who did purposely, they did badly. He is in a big, big illusion about those boys. So we have had to inform the shipping company regarding the conduct of the boys. And now he's asking questions. Why did those boys score zero purposely? Some of the boys are quite high ranked and they have purposely scored zero in the NYK tests. And believe me, director and myself, we were with the NYK officers that day, we were literally begging them to take some more boys. And then they showed us the paper answer script of the boys. Director Saab, Mr. Mukherjee, see how the boys have done. They have got 0 out of 100. On what basis can you request us to take these boys? You see, director's face became so small. I also became so upset that we had no face to request them to take more boys. That was the situation. How we can ask them to take more boys if the boys are purposely scoring 0 out of 100 in that test? So then we decided to take action so this thing doesn't happen again. So we banned those boys from appearing from any more placements. And then they were crying. So now director said, all right, let them give their names, but we will have to inform the company regarding their conduct. In other words, if there is any disciplinary measure against them, after that, let the company decide. So we have put that across to fleet management. Now fleet management doesn't know what to do. Should they take the boys or should they not take the boys? They want academically bright boys, but they want character also within the boys, discipline also within the boys. So these are the aspects that make a proper engineer. It is not scoring first rank, second rank, you become the best engineer. That is not the way it is. It is your attitude, it is your discipline, it is your character. All these are matters which make you into a good employee. A supplementary holder, a arrear paper holder might become a much better engineer than a top ranker. And I've seen that in my experience. I've had batchmates who were supplementary holders, then they became chief executive officers of shipping companies, fleet managers of shipping companies, superintendents of marine engineering companies, and the top rankers remained chief engineers. So that is the point. It is not just getting very high academic records that will make you into a good engineer. Your basic attitude, character, discipline, all these parameters are what you learn in your 4 years in the campus. That is why we are so strict about fall-ins, shave, haircut, beard. These are all ultimately developing a personality within you. So you need to follow. If you want to be a good marine engineer, you need to follow the rules. You need to follow the rules. The institute is a very good institute. The rules are also very good. All you need to do is follow those rules and you will become an engineer. But if you think of dodging, bunking, cheating, taking all the shortcuts, then you don't. Then you don't. Then you might become, cunning. Cunning is not a very, is not a very um, favorable trait within a person. A clever person is respected. A cunning person is not respected. Remember. So cunning is not a characteristic I would encourage in our students. Okay. So let's go back to our subject. We've lost a lot of time, 10:25. Okay, so this is the last of crankshafts that we are discussing. If you have any questions regarding these crankshafts, do ask, because the next subject, what we are going to talk about is the exhaust valve. The, sorry, the hydraulic exhaust valve. The hydraulic, before we discuss hydraulic exhaust valve, let's talk about the ordinary valve. Here is the diagram of an ordinary valve, and it is worked Let's read it first. The exhaust valve, the ordinary exhaust valve, is operated by a cam on the camshaft. The cam lifts the push rod to actuate the rocker arm, like a lever. The tappet at the end of the arm pushes down on the valve stem against the spring force to open the valve. The opening and climbing of the opening and closing timings of the valve are fixed because the rotation of the camshaft relative to the crankshaft is also fixed. So the opening of the valve is completely a mechanical operation. All right. So whatever position the crankshaft is, it will have a relative position of the camshaft and therefore a relative position of the valve position. All right. So this is the camshaft which is being operated, and on the camshaft you have a cam. You see this protruding part is called the peak of the cam, and this cam pushes onto the roller which is in the push rod. This rod here is the push rod which will push up the lever which is the rocker arm. This is the fulcrum of this particular lever, and this is a bolt with a bulb or rather round bottom portion over here. This is a special type of a bolt. On the top of the nut, and at the bottom is a round portion which falls into a recess. And in that recess, few drops of oil are there. So because it has a bit of a rubbing action, as it keeps pushing, it has to have, it's like a ball joint, half ball joint. So as it keeps pushing, the rocker arm bends. And as it keeps bending, it pushes the stem of the valve against the spring force to open the valve. So this is how a normal mechanical valve works. In the smaller engines, you need not have a push rod, you need not have a rocker arm like this. You can have this cam directly on top of the valve itself. So the cam itself will automatically push down on the valve to open the valve. These are called OHV. Sometimes on old cars, you will see OHV written, overhead operated valve. That means the cam is directly operating the valve and there is no need for a rocker arm or a push rod. So these are the mechanical valves, and I hope you understand how the exhaust valve is here. In our workshop, on the table, on the workbench, you will find the smaller valves are there. So, okay, so this is an exhaust valve which is largely used mainly for a four-stroke trunk type of engine. All right. Okay. Now in the two-stroke engine, you also have rocker arm arrangements, but they are now outdated. They are finished. They are history. They are fit for the Smithsonian Institute. You have what are called hydraulically operated valve. So in a hydraulically operated valve, you have an actuator or it is like a pump, and that pump continuously presses oil, and that oil is ultimately under pressure is sent on top of the valve where there is a piston, and this is a piston on which the pressure of the oil acts, and this piston is directly pressing down onto the spindle, and the spindle is pushed open. All right. This particular valve, this hydraulically operated valve, does not have any coiled springs. All right. It does not have any coiled springs like you see what it has here. These are the springs that you see over here. And these springs help to keep the valve pushed up and closed. Okay. All right. Now, in the case of the hydraulic piston, you will have an air spring. You know, air is compressible, and because of its compressibility, it is used as a spring. If you have tried to pump a cycle tube with a pump, you will find there's some amount of springiness in compressing air. So the same feature is used in the hydraulically operated exhaust valve. Now, one particular area you need to understand here, which is in the scope of your practical work, is tappet clearance. See, when the valve is seated, where is it making contact on seating? Obviously, at this lowest point over here, where the valve disc, that is the circular part of the valve, goes and rests on the seat. All right. This seat is a special ring actually. And on this ring, you have a metal which is deposited through welding. And this metal is a very special metal. It is called stellite. It is resistant to wear, resistant to burning, resistant to corrosion. So it's a very complex, not very complex, it's a combination of cobalt, boron, manganese, silicon. So it's a combined component which is welded on the seat. Likewise, on the valve disc also, you have this stellite metal deposited through welding, and this prevents wear, corrosion, and gives a long lifespan for the valve. Okay, but that is another part of the story. So you understand that the valve, when it is closed, it has to seat itself at this edge here. So in other words, there should be no other pressure on the valve from the top, which might keep the valve pressed down and open. So that is why when this rocker arm actually presses down on the spindle, when the valve is closed, there has to be a clearance here. When the clearance is here, it means this cam is on the base circle. Right now, you see it is on the base circle. It is not with the cam at this position. The cam peak is off from the push rod. So right now, it is on the base circle. That means the rocker arm can go down on the right hand side as much as possible. And therefore, there will be a clearance existing over here. This clearance is called tappet clearance, and it is a necessity for all exhaust valves to have this clearance. This enables the valve to be seated on its seat, and it also enables any differential expansion when working. Now, what is differential expansion when working? See, when you adjust the tappet clearance, the engine is cold. All right. When the engine is working, sorry, when the engine is stopped, that time the engine is cold, and that time you adjust the tappet clearance by means of a feeler gauge. How do you adjust it? You see, there's a nut over here. This nut has to be opened, and then the tappet bolt, which is there, it is called a tappet bolt, and it's a special bolt with a very hardened surface underneath. So tappet bolt can be unscrewed, so it lifts. It will increase the tappet clearance. So you can put the feeler gauge inside and adjust the bolt first to the required position to get that clearance, and then hold that bolt in position with the help of a screwdriver and tighten the nut to to fix that bolt in that position. So that bolt will not move any further, and you have a required clearance at the between the tappet and the spindle of the valve. So this is essential to ensure that the valve can reseat properly without any gap at the bottom. And second is the differential expansion. Differential expansion means when the engine is running, that time the spindle is going to expand, isn't it? So if it expands, it is going to reduce the clearance. All right. If it reduces the clearance, then the clearance is no longer the same. If it reduces the clearance of it makes contact, moment it makes contact means the seat will come off. This will open out. So that is why you need to have some amount of clearance at the tappet. That is the reason for tappet. One, to ensure the valve is seated when required at all times. Okay. It should never be a position where there is some pressure on the spindle and it has kept the valve open. So when it is on base circle, the valve has to be closed. In other words, there has to be a clearance here. And allow any thermal expansion, this clearance will accommodate that. Thermal expansion is in microns, hardly anything, because it is not only the valve that is expanding, all the components are also expanding. So the clearance is essential for Two reasons. First one, to ensure that the valve is always closed when required. Second one is for thermal expansion. Okay. So this is your normal exhaust valve. Now let's go on to our hydraulically operated exhaust valve. Okay, now here is your hydraulic exhaust valve. The modern two-stroke engines have a centrally located exhaust valve. The valve is located on the top of the cylinder. If you saw in the previous diagram that I've given you, on the top of the cylinder head, you had the fuel injector. But now that fuel injector is no longer there. You have a differently designed cylinder cover in which the exhaust valve is fitted, and this exhaust valve is right in the center. The injection valve are on the sides, and instead of one injector, you may have two, you may have three. Okay, but that is another story. Let's do our exhaust valve. This exhaust valve is hydraulically operated through an actuator using the engine system lube oil. That means crankcase oil is used to work this particular uh, valve. I'm increasing the size to help you to actually see it. Okay, so let's have a look at it. I hope now it is much clearer. I will reposition it when I finish. A little smaller. Okay. Now here is your exhaust valve, and it is a colorful picture for you to understand. Do not assume you have to draw this diagram in the exam. I have a simplified diagram in the later pages, which I will show you, and you can practice that diagram. Now, this is the exhaust valve, and you see the spindle is still the same. There are little changes in the spindle, that it has got some veins on the surface. These are plates which are welded on to the spindle at an angle. I will explain to you what this is later. First, let us see the valve in totality. This is the actuator. It is a pump, all right? And this pump is operated by the engine only, like a fuel pump. And this pump pumps oil, the same lubricating oil that is in the crankcase. And this oil goes up on top of the valve, where there is a, you see there's a blue colored piston. This piston is the hydraulic piston. So the oil which comes on top of the piston, when it is under pressure, it will push the piston down, and the pressure is retained. If there is another vent over here, this vent is not properly shown. This vent will operate by means of a computer signal. And when that computer signal allows the vent to open, then the oil will be released from that vent. Okay, if the oil is released from that vent, that means the spindle has the capacity to come upwards, because all the oil which was creating the pressure will have dropped in pressure. Now, how does the spindle come back into position? Now, on the spindle at a lower region, you have another piston. This is a piston which is welded to or fixed to the spindle. This is a piston, all right? And underneath the piston, you have compressed air at 7 bar. This air supply, which you see on the right hand side, is allowed to come into this chamber, which is below the piston. The moment there is an air pressure under the piston, it will force the piston upwards. And because the piston is fixed to the spindle, it will draw the spindle upwards. And once it draws the spindle upwards, the valve you see at the bottom will become closed. Once it is closed, obviously the spindle can't rise anymore. Okay, but the oil from the top has been vented out, and the valve is now closed. Again, depending on the cam position and the computer setup, the computer is what gives the signal for opening the valve. The whole procedure is computer operated. In other words, when the valve will open, how long the valve will remain open, when the valve will close, the rate at which it will close, the rate at which it will open, all are computer operated. Okay, all these settings are made with the computer, and that computer will ultimately send a signal for operating the vent valve. And this vent valve will automatically allow the oil pressure to be released or retained above the hydraulic piston. Okay, so that is how it works. Now let us see the rest of the valve. You understood that there is a piston which is welded onto the spindle, and the air which is coming in comes and forces the piston upward. Now, this pressure is always there. In fact, if this pressure is not there, the engine will stop. Engine will not run. This is called air spring supply. And if this air pressure is not there, the engine will not only not start, it will not run. So that is one of the safety features of this type of engine, that this air supply is as important as the lube oil pressure of the engine. It is as important. So this pressure here keeps the valve closed. Now, if you shut down the engine, shut off the air, what will happen? This spindle will drop. It will drop and it will come out in the open position. And if the engine is stopped, nothing is happening, the valve is fully open. It will drop till the piston comes and rests on this guide over here. What you see in this brown color piece over here is actually a guide. This is made of cast iron. And I told you cast iron has got good lubricating properties. So this is actually helping the piston to slide inside, up and down, depending on the position the spindle has to be in. Now, this guide, if you see, is got a passage, a capillary passage. This capillary passage is to permit some amount of oil which is coming with the air supply. This air supply which is provided has got some amount of oil vapor. This oil vapor is ultimately allowed to pass with a little bit of air into this space between the spindle and the guide. So the entire surface is now coated with oil, lubricating oil. This oil helps to lubricate the spindle between the guide and the spindle. Okay. Now, any excess oil that might gather here from the oil vapor which will condense is allowed to be drained out from this passage. Likewise, any oil which comes beyond the hydraulic piston and falls into this space is allowed to be drained out from that space. The valve casing or valve housing that you see is water cooled. So you see this blue space, and this is the part of the seat that has bore cooling. Bore cooling is cooling of any component through narrow passages. And this passage here is a very, very narrow passage, and the maximum heat developed is also in this particular area. So this path is called bore-cooled exhaust valve. This is the casing, and of course, the exhaust gases are passing out continuously from here. Okay. Next point is what we need to make you understand is why are we required to have the valve continuously rotating? Even in the ordinary valve that you saw, there is an arrangement which helps the valve to rotate continuously, albeit about it takes anything between 45 seconds to 1 minute for one complete rotation. That means it's a very slowly rotating valve spindle, very slowly, but it is necessary. Why is the reason? Okay. Now you see the hot gases, when they escape, when the valve is open, they escape through a flow, and the path of the gas is through one direction continuously. So there is a possibility of the air or the exhaust gases coming out from this side faster than what is coming out from this side. So the flow of the gases is not even past the spindle or past the disc. So there is every possibility of the disc getting more heated at one point and less heated another point. So if you cause uneven heating of that valve disc at the bottom, there will be uneven expansion. And moment there is uneven expansion, then the seating of the valve will not be uniform right through. Okay, so we need that valve disc to be of even temperature all around. But the flow of gases is not uniform around the valve to give uniform heating of the valve. So because the flow of gases is uneven, the heating of the disk is also uneven. And to change this uneven heating to even heating, we keep rotating the valve. So all around the valve, the heat is given to bring it to a steady temperature or even temperature. When you have even temperature, then the expansion of the disk is also even. So the seating of the valve on the seat is also even. So there is no distorted seating which will cause the valve to leak. One. Number two, as you keep rubbing the seat against the valve seat, there is a grinding effect so that if any debris falls on the seat, it gets rubbed off. So it cannot remain lodged in that position to cause incomplete closure and therefore leakage. If any debris gets lodged on the seat, then the valve will not sit properly. If it doesn't sit, there will be leakage. So it continuously grinds off that surface to give a uniform seating of the valve on the seat. Okay. Now, how is this valve rotated? This valve is rotated by the exhaust gas itself striking or moving past these vanes that you see. You see, the ordinary ceiling fan or even a table fan, if you blow air on it, it will start rotating on its own. All right. Okay. So once the exhaust gas keeps passing and blowing over these vanes, this gives a torsional effect or a torque because the angled blade will cause the change in direction of the exhaust gas marginally. And this will cause a torque on the spindle and thereby help to rotate the spindle gradually. How gradually? About one revolution in 45 to 60 seconds, sometimes one per minute or three quarters per minute. All right. So that is how it works. Any questions you have, do not hesitate to ask if you want more clarification. Oops, sorry. What happened? Yeah. Okay. So have you understood? Have you taken, got some concept of how the exhaust valve is going to work?
Yes, yes.
Okay. Let's move on. Let's now we have the read up. A hydraulic actuator pump sends oil under pressure on top of the hydraulic piston to force open the valve. Okay. Towards the end of the power stroke, the oil pressure is vented. This venting is completely computerized. All right. Computer operations will help to release the pressure on the hydraulic chamber. Instead of springs, the valve has an air spring. This air spring enables the air piston to lift and close the valve. Remember, the air spring only helps in closing the valve. Opening is by hydraulic pressure, closing is by air pressure. Okay. Piston to lift and close the valve with air pressure at 7 bar. So the air pressure which is supplied, it is at 7 bar. So air has small amounts of oil vapor which provides lubrication to the valve stem and guide and seals the gap around the stem. Okay. Okay. Now this is the diagram I have drawn to make it as much as possible for you to be able to draw. You will need to practice this diagram and you need to be very thorough with it because I've seen almost every exam, the exhaust valve is always there. Sketch and describe the exhaust valve, explain how rotation of the valve is achieved and why rotation of the valve is required. Okay, so you get very, very intricate questions on the exhaust valve. What is the advantage of having an exhaust valve instead of ports? I think I asked that question in the class test. And fellows have given me, I wasn't very happy with the answers. See, what is the advantage of having an exhaust valve instead of exhaust ports? So everybody says, oh, there is a change in design, then everything they have said except what was required. The essential advantage is that the timing can be changed. The timing of opening the exhaust can be changed at will. You want the maximum efficiency from the exhaust gases, you can open it later or you can open it earlier. So the maximum energy of the exhaust gases can be utilized to give optimum performance of that engine. So the main thing is that the timing can be changed for the exhaust process. That is what I wanted, but most of the boys didn't give that. Okay. So next is here I have the same diagram, which is you need to know the names of the parts very well. Once you know the names of the parts very well, it becomes easier for you to actually put them down when you draw a sketch. The same colored diagram is now seen in a black-white form, and the relevant parts of the valve is damping. Oh, I have not explained. Let's go back to the subject. Yeah. Okay. Now here I explained to you how the oil pressure on top acts and pushes down the valve. All right. Very fine. And then when the oil pressure is released, the air pressure under the piston closes the valve. Okay. Now if it closes the valve, you see there is a damping pin with a spacer here. What is the purpose of the damping pin and spacer? See, this damping pin, it ensures that the lift of the valve is up to a certain amount. In other words, the valve can come up and ensure that there is nothing else pressing it down. This damping pin is made in such a way that the diameter of the pin and the diameter of that recess in the hydraulic piston is more or less the same. That means when the damping pin fits into the recess, there's a very small clearance around it. Okay. Now, when the valve is closing, it gradually goes up, 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 and the hydraulic piston moves into the damping pin. You can see the diagram, it moves into the damping pin. And moment it starts moving into the damping pin, the rate at which the valve closes is reduced. Why? Because the oil under the damping pin and inside that recess has a very limited area for escape. It is like an orifice plate. An orifice plate is a plate with a small hole in it. So the rate at which the oil can go out is reduced. Moment it is reduced, then the pressure, the piston which is pushing that oil will also reduce its speed. This is similar in function to the automatic closing doors you have in offices. If you see, I open the door and I let go of the door. So the door swings and then it comes very close to closing and then it slows down and closes afterwards. So when it closes, it comes very quickly up to the point and then closes and very gently closes against the seal. It doesn't go and slam. So that slamming effect of the valve is reduced by means of this damping pin. That is why it is called a damping pin. What does it damp out? It damp out the slamming of the valve on the seat at the bottom. Otherwise, the seat will get damaged. You get it? So the damping pin, which is partly into the hydraulic piston, helps to reduce the rate of closing of the valve. How? Because the recess in the hydraulic piston is of a similar diameter as the damping pin. So when it goes in, the oil in the trapped space has to leak out, and it leaks out through a very small passage. And this provides the damping effect. That was one. Number two, remember, under no circumstances must the damping pin touch the hydraulic piston at the bottom of its recess. And that clearance is actually similar to tappet clearance. Now here I have the diagram which I have shown you clearance. I should have made this a little with a mark. This clearance is what is the tappet clearance over here. This clearance ensures that the valve can be seated at the seat over here. Okay, all right. I hope you've understood this part. This part is very important. Why is the damping pin called a damping pin? Oh my God. The computer battery is going down. Okay, now it is all right. So that is what the purpose of the damping pin, and that spacer is nothing but a washer under the head of that damping pin bolt. That spacer decides what will be the tappet clearance. You can change the spacer to increase or decrease the tappet clearance. I hope you have understood. If you have questions, ask, then I can clarify. Now, this is the diagram showing all the components. Let's go to the relevant parts. Damping pin with spacer, that is right on top. Hydraulic piston, that is the piston below the damping pin. Next is air spring piston. There is an air spring over here. It's called an air spring because it is pushed up by means of compressed air. Then you have the valve guide. The valve guide is what you see over here on the sides of the spindle, and it is made of cast iron. And you know the properties of cast iron and why it should be used here. Next is the valve spindle. The valve spindle is the central piece, which is the valve actually. Then you have the vanes. The vanes are what composes the valve rotator. These vanes are actually plates which are welded onto the spindle, and they are at an angle. This angle helps in causing the gas flow over the plate to give it a torque, a rotary movement, similar to the angles of the ceiling fan or a table fan. When you blow air over it, the fan will start rotating. The same principle is used here. Next, other than the vanes, you have a capillary passage. You see the small little passage which is coming from the air spring chamber down into the guide to carry some of the lubricating oil and little air also. Little air will definitely come with that. So this air helps in preventing exhaust gas from coming into the space, or it helps in preventing excessive leakage if the guide clearance is too much. Okay, so these are the parts. That is why the capillary passage, I call it capillary passage because it's a very thin passage, very small passage, almost like a needle, as thin as a needle. And the last is the actuator, which is the hydraulic pump. Okay, let's read it. Cooling water spaces ensure that the valve is not overheated. Narrow passages in the valve cage enables bore cooling. Okay. Narrow passages in the valve cage enables bore cooling. Vanes on the valve stem enable rotation of the valve, thereby ensuring even heat distribution at the valve seat. The valve seat is where the valve disc is, the circular part of the valve, large diameter. This avoids distortion of the valve disc so that the disc does not change its shape. And I'm talking about microscopic change in shape. You don't see it bending, you can't see it. It is microscopic. And that microscopic change in shape will cause the valve to be unseated. This also removes any dirt, debris sticking to the valve seats and enables uniform wear to give uniform seating and sealing. Excess oil from the hydraulic cylinder and air cylinder are drained out. I showed you the drained passages. Advantages of the hydraulic valve. Hydraulically operated exhaust valve. The timing of the opening and closing can be varied and controlled. There is no transverse thrust on the hydraulic actuators. Thus, axial is axial to result in less guide wear. You see, what actually should have been here, you'll have to go back to the first diagram. Yeah. You see, when the pressure of this rocker arm is acting on this, it is not exactly a vertical force. It is an arc. All right. So this has a tendency to have a sideways force on the spindle. This sideways force on the spindle ultimately has an effect on the guide over here. So this causes excessive wear. So this wear down is removed if you remove this rocker arm. So in most cases, the rocker arm is removed and you will have the actual cam working on top so that there is no sideways thrust on the spindle to cause excessive wear on the guide. So that is what he means. So no transverse thrust on hydraulic actuators on the spindle. No transverse thrust on spindle of the valve. Thrust is axial in the case of hydraulic system, thereby result in less guide wear. Thrust is axial in hydraulic system to result in less guide wear. In the hydraulic system, the pressure is vertical, absolutely vertical. In the ordinary rocker arm arrangement, it has a thrust to the side, very small, but there, nevertheless, it is still there. So this causes the guide to be worn out on the side. Sure, never mind, forget it. Somebody is calling on the phone. Next is, the hell is that, Manika? I hope it is not from the company. Let's finish it. Controlled landing speed from the air return spring ensures minimum stress on valve and seat. Controlled landing speed means dampened seating. So the valve does not slam on the seat. So there is a damping effect. So this landing speed is controlled. How? I told you, by that damping pin and the recess in the hydraulic piston. So when that damping pin enters the recess of the hydraulic piston, the oil is trapped inside. And this oil has to escape from the sides of the damping pin. And this rate of escape is very slow. So the seating of the valve is also very slow. So that is why it is called controlled landing speed of the valve. Valve will not slam on the seat. The vanes on the spindle help to rotate the valve, ensures even thermal and mechanical stress and uniform valve seating. I hope that is clear. You understood what it means. So we finish this PowerPoint. This PowerPoint has got 46 plates. It's a long one. So anyway, I will share the lecture with you, but I hope you have understood the crankshaft
Well,
and the
sir,
exhaust.
excuse me, sir. So
Yes.
if it's possible, then can you maybe share this PPT with us as well, sir?
Sorry, come again.
So
If
if
it
it's
is possible.
possible, then can you share this PPT, this presentation slides with us too, sir?
Okay. Okay. Okay, that will be all. I have already
Yes,
taken
sir.
up 11:06. It's almost time. They will be late for the other class. Then the other teacher starts calling me up. They say that, Mr. Mukherjee, you're still holding our boys. Okay, bye bye. Take care of your health and take good care of your studies also. It is going to be a prolonged online classes, and your exams also will be online if I can guess. So be thorough with your subject matter. Okay, bye
Yes,
bye.
yes, sir.
Bye
Thank you,
bye
sir.
and take care.
Thank you, sir.
Yes, sir. Thank you,
Okay,
Thank
sir.
you, sir.
okay, bye bye.